Hey you beautiful amorphous blobs, Ribka here. Today I want to talk about, as the title suggests, an automated anywhere-to-anywhere boat transport network. Anywhere to anywhere means that passengers can enter the network at any terminal and be routed directly to any other terminal. The network I've built here achieves this by using a tag matching system to encode and transmit the passenger's destination. Behind me is the intersection design I came up with for this video, but I want to emphasize that this is just a proof of concept. The designs in this video can certainly be improved upon, and for that reason, I'm only going to talk about how they work in general. If you want to look more closely at these particular designs, I've left a link in the description for the world download with structure files included. Now, let's get into it. Automated boat transport networks function off of a few basic mechanics. 1. Boats can be dispensed with specific facing directions. 2. Boats will change passengers' facing directions upon being entered. And 3. Chest boats can carry items alongside their passengers, which can be used for tag matching within the network. Together, these mechanics allow for destination information to be carried with passengers and for passengers to be routed according to that information. The intersections in this network route the passenger by dispensing a boat that is within line of sight of the passenger and facing in the direction of the passenger's destination. When a boat containing a tag arrives at an intersection, it is broken, and the tag is picked up by a hopper minecart and tested against tags and chests representing each of the 4 exit directions from the intersection. When a matching tag is found, the minecart is redirected, triggers the proper dispenser, and leaves the tag in a hopper which inserts the tag into the newly dispensed boat. The passenger, holding the use and walk buttons, enters the boat and continues toward the proper destination. Tags, boats, and minecarts are each recycled, such that no resupply of intersections is required. Turns function similarly to intersections, except tags are not checked. The terminal design I've used has a signal strength based 16 option selector array that determines which hopper is unlocked when a boat leaves the terminal. Each hopper contains a specific destination tag which matches the choice from the selector array. Tags are removed from arriving boats and returned to the terminal's supply. Automated boat networks have various benefits and drawbacks. Automated boat placement requires water. Boat networks will not work in the Nether, meaning they cannot take advantage of the 8x speed scaling of Nether travel. For these networks to be fully AFKable, passengers need an automated way of holding down the walk forward and use buttons. This can be done without mods or macros by binding both controls to mouse buttons, holding down both buttons, and pressing F3 and T. This reloads the game's textures, and upon reloading, the controls will be stuck on. Boat network travel times scale by taxicab distance, which is the sum of the distances along the X and Z axes. In contrast, rail and piston boat network times scale by Chebyshev distance, or the maximum of either the X or Z axes, and elytra travel scales by Euclidean distance. This means that, for diagonally positioned destinations, boat travel times are extended relative to other travel methods. However, boats on ice travel significantly faster than each of the other above methods, achieving top speeds of about 73 blocks per second on blue ice, or 40 blocks per second on packed or regular ice. The resources boat networks require compared to piston boat networks differ. For each 100 blocks of travel, a standard demi-boat requires 100 repeaters, 50 pistons, 50 rails, 50 powered rails, and 100 solid blocks, while a boat network requires 50 blue ice, or packed or regular ice. Which of these resources is more difficult to supply will depend on farms available to builders. However, it is worth noting that placing ice every other block requires less effort than constructing a piston boat. Also, in tag matching based networks in general, tag supplies at terminals slowly become unbalanced during use, requiring regular resupply. That's about all I have to say about this type of anywhere-to-anywhere network. I hope I was able to effectively convey how automated boat networks function and why or why not someone might use one. Again, the designs I've overviewed here can be improved upon, so I'm excited to see what other people can come up with in the future. Thanks for watching.